To begin talking about Photon views, I'm going to utilize my game scene. So go ahead and open up the game scene. I'm going to go to the cube, add component, and then add a Photon view. We'll actually be using this later. A Photon view is essentially the network identity of the object. So each view ID will be unique. You don't have to assign it. It will automatically be assigned as objects are instantiated. On the top, you have owner, scene, fixed. The owner is who controls the Photon view or the object it's attached to. This is typically who you want to make all of the calls through. So if you are trying to move an object, typically only the owner will try to move the object. When it indicates that the owner is the scene, that means that the master client ultimately is going to own this object by default. It's pre-placed into the scene, and the master client owns scene objects. Then you have fixed. You can click the drop down and you have takeover and request. Fixed means that the object cannot have its ownership transferred. Takeover means that you can take over the object without requesting to do so, meaning anyone can take over ownership given that the code tells it to. And request indicates that anyone can request to take over ownership and a response is required to actually transfer it over. I'm going to go ahead and leave it as fixed for now. Next, you have the observe option. It's set to off by default because we don't have any observed components. You have reliable delta compressed, which is similar to RPCs where it ensures the data is sent through. This can also hog your network like RPCs can, so only use this if you absolutely necessarily need the data to send through in order and every time. Next, you have unreliable. This means that data is sent continuously, and in addition, it can be dropped. So if you're sending, say, the movements of an object, and if perhaps it's going from point A to B at 0, 1, 2, 3 steps, steps 1 and 2 might get skipped and it might just teleport to 3. That's not necessarily a bad thing. It just means that the network can't handle the traffic, and that's like any other game where you see lag skipping. Lastly, you have unreliable on change. This is the same as unreliable, except it only sends data whenever it changes. This is the most commonly used one. Next, you have observed components. These are components that are affected by the observed options. If you have nothing in here, then nothing is sent on a regular basis, meaning whether it's changed, unreliable, or reliable delta compressed, this doesn't apply when there's no observed components. You can still call RPCs and events, which we haven't talked about yet, without having observed components. In fact, anything that makes calls over the network to other clients must use a Photon view. Observed components could be a variety of things. There are custom components like the Photon animator view, rigid body view, transform view, view classic, and many more actually that you can have automatically sync up or be observed by the Photon view component. So I'm going to add on the Photon view and not the classic one, the regular one. It doesn't necessarily matter what you use. I'm just going to use the regular one in this example. So by default, it has position and rotation checked and scale unchecked. That means scale will not be synchronized over the network. I'm okay with this as is. So I'm just going to hold and drag in the Photon transform view and drop it in the observed components. You can also add more with the plus sign and remove current entries with a minus, just like you could with any other list in Unity. You could also observe script variables. That's something I'll be covering later on. Next, however, I'll be talking about events.